Hello, my darlings. Okay, so today we're going to look at another technique that we use before integrating, and that's completing the square. Now, before I show you an example where we're going to complete the square, I want you to look at this first problem that I have. This is after I've completed the square. It might look something like dx over the quantity x plus 1 squared plus 4. Notice that's like 1 over u squared plus a squared, or the tan inverse, okay? That's going to integrate to tan inverse. But that means our u is x plus 1, and our a is the square root of 4, which is 2. Now, if u is x plus 1, then du dx is 1, or du is just dx. So this becomes the integral of 1 over u squared plus 4, or you can put a squared there if you prefer, du equals 1/2 the tan inverse of u over 2 plus c, right? Just taking it right out of the model that we had. Then all we have to do is replace, if you used a instead of the 2, you're replacing the a with the 2 now, okay? So in other words, you could have done 1 over u squared plus a squared du gives you 1 over a tan inverse of u over a plus c, and then you would substitute in the 2 and the u, which is x plus 1 over 2 plus c. And here, on the original way, we only have to substitute our u, which is x plus 1. So either method works, and whichever one you're most comfortable with, go with. Okay? All right, so now let's suppose I give you something like the integral of dx over x squared plus 4x plus 8. When you look at this, you say, oh goodness, what do I do? Well, you try to okay, I have a fraction, let's let the denominator be u. And if you do that, u equals x squared plus 4x plus 8, but your du dx would be 2x plus 4. We're not going to be able to cancel that out, which means we're going to have u's and x's, and that's no good. That means this method does not work. Okay, so we start again. We say, okay, that's no good. And now we have to look for another way to do this. So this is where we're going to complete the square. So let's take this denominator, x squared plus 4x, and I'm going to leave some space for completing the square, and I still have the plus 8. Now, if I'm adding something inside the parentheses, I'll have to subtract the same thing outside the parentheses. Now let's get ready to complete our square. X, I'm going to close it, squared. Now, half of 4 is 2, and 2 squared is 4. So if I add 4, I have to subtract 4. And 8 minus 4, that's plus 4. So this is going to be my denominator now that I've completed the square. So we're going to have 1 over x plus 2 quantity squared plus 4 dx. Now we can look at this and say, okay, my u is x plus 2, and my a is the square root of 4, which is 2. And du dx is 1, so du is dx. That means I'm going to have the integral of 1 over u squared plus a squared du. Now if I integrate this, that's again in that arctan form. So that's 1 over a tan inverse of u over a plus c. So that becomes 1 over a is 2, tan inverse, my u is x plus 2, over my a is 2 plus c. There we go. Another one done. Here's another one. Let's try this one. Okay? So again, if I look at that x squared minus 4x plus 4, if I let the denominator be u, my du dx is going to be 2x minus 4, and I don't have a 2x to cancel that out with. So I would have u's and x's. That's not going to be good. So we're going to try to complete the square. Now, you may realize that it is a perfect square, And you might see that right away, but if you don't see that it's a perfect square, you're going to say, okay, x squared minus 4x, and I'm going to add something, and I have a plus 4, but if I add inside, I'm going to have to subtract it outside. What's half of negative 4 is negative 2. Negative 2 squared is 4, but if I add the 4, I have to subtract 4, and notice this part equals 0. That's because this was a perfect square to begin with. So if you saw that right off the bat, that would have been easier, and then you would just rewrite it as the quantity x minus 2 squared dx. So now we look at that and say, what can we do? Well, now I have a fraction, so I'm going to let my u be x minus 2, and du dx is 1, which means my du is dx. So I can now rewrite this integral of 1 over u squared du. And that, remember, is the integral of u to the negative 2 du. And the antiderivative of that, I add 1 to the exponent's negative 1, and when I divide by negative 1, plus c. So I'm looking at negative 1 over u plus c. And if I do that substitution now, my u is x minus 2 plus c. Here's my final answer. Awesome. One more problem, just to make sure we recognize the form. This problem has already done the completing the square, okay? The completing the square part has already been done. It's in the form where a is, right, a squared is 4, u squared is x minus 1 squared, so a is 2, and u is x minus 1, which means du dx is 1, or du is dx. Now we can rewrite this as the integral of 1 over the square root of a squared minus u squared du. That's the sine inverse form. So the rule for sine inverse is sine inverse of u over a plus c. Now we substitute back in sine inverse. Our u is x minus 1, and our a is 2 plus c. And there we go, my dears. All right, so we're going to practice more with completing the square and then integrating. So remember, if you can simplify the integrand, it makes it easier to integrate. Have a great day.